Hello, welcome to the machine learning at home. Today I will speak about things which are very important for the machine learning tools, about dummies and duplicates. Dummies is a statistical method to convert characters into numeric. So suppose you have some categorical characters. To me it is much better to make a sample first. So let us make a sample. We will make an object with the name EE, which will be just a subset of letters, a sample of letters. Letters from 1 to 5. 1 to 5, so A, B, C, D, E. And then I will sample them 10 times and allow replacement. Place equal to 2. And I will need to see the object immediately after creation, so I put external parentheses. So exactly what I want, so A, E, D, E, and so on. So now I want to convert these categorical values, like different characters, into numbers. There are many ways, and all of them are imperfect. One of interesting way is to create dummy variables. The best way is to show it practically again. So let me run my own package. Library Shipunov, and then use command to bin, which converts categorical characters into numerical, to binary, so 1 and 0. So to bin EE will make a table. Look on the table. It has 5 columns, one for each type of letter, for A, B, C, D, E, and then each column will tell us which letter is a particular position in our EE vector. For example, A is only in the first place. So here is 1 in the first place in the A column, and 0 in the first place in all other columns. So this is a way to create numerical characters from categorical. There are actually 2 ways to do it with function toBin. Second one is even faster, and instead of making new names for each column, like ee.a, ee.b, it will simply leave names of column as exactly names of characters. So first column will be A, then B, C, D, E, without ee dot. So let me show how to work with it. toBin EE convert dot names equal to false. And this is even simpler, and by the way, this method works a bit faster. So the same table actually doesn't change, only names of columns are different. And now you can do whatever you want with this table. So for example, to apply any methods of machine learning, you can use conversion of categorical characters into binary, and then use any methods which works with numbers. So this is a very important thing. And if you want, of course, in CRAN, in a place where you can download R packages, there are plenty of packages which doing this dummy variable approach. So simply search for dummies or dummy, and you will find plenty of packages which can do it. So my function is only better because it's faster and flexible enough. I like it this way. Now something else, but also important: duplicates. So frequently you deal with duplicates in your data. So let me create some very duplicated data. So data will be called AA, and it will consist of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different elements. So I will use C for concatenate, and then use 12 pairs of quotes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then separate them with comma. And then fill inside quotes. So let me make first element 1, then 2. Nothing interesting so far. Next one will be more interesting. Empty character string. Next one also interesting, just NA without quotes. Next one will be 2 again. Next one will be 3. Next one will be 3 again. Next one will be NA again. Next one will be empty character string again. 1, 2, empty, NA, 2, 3, 3. Oh, actually I need a 3 third time. Let me do it here. 3 here, then NA, then empty character string, and then 4. And actually I need less. Okay, so let me do it like that. Whew, done. A bit complicated, but it's good to demonstrate how to deal with duplicates. So this data set has plenty of duplicates of different sorts. There are duplicates of character strings, duplicates of empty character strings, and duplicates of missing data, of NA. So 3 different types of duplicates. And now how to deal with duplicates in basic R. So I can apply 2 base functions. First function is unique. Unique AA, which will simply show us unique values in that vector, unsorted, but function is working fast and will show you which are unique values. So 1, 2, 3, 4 plus empty character string and NA. Very nice. But how to determine which values? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How to understand which of these 11 values are duplicates? Okay, there is function duplicated. Duplicated AA. But it doesn't show exactly what most people want. That's a problem number 1. It doesn't show, for example, that 2 has duplicates, because you see 2 correspond with false here and then correspond with true here. Let me show it better. I will create data frame. So it will be shown as 2 columns. First column we call V equal to AA. Second column we'll call dubs. It will be equal to duplicated of AA. Okay, and then you see them side by side. So look, 1 is not duplicated. This is absolutely correct. So 2 is duplicated because there is second 2 here, but second 2 labeled as true and the first 2 labeled as false. What's going on? The same situation is with here and with here and also with 3. First of 3 is false, not duplicated. 2 others are duplicated. This is because R will mark only second and so on duplication as duplicate. The first one is not marked as duplicated. So this is thing which some people are unaware of, and it might be, well, source of mistakes, and it's not so handy. So first of all, my function all dubs will make marking all duplicates, not only the second, third and so on, but also the first one. So let me show how it works. Let me make same data frame, but function duplicated I will replace with all dubs. As you see, now only 1 and 4 are not duplicated, which is absolutely true, and 2 is duplicated from the beginning, and all 3s are duplicated. Both NAs and both empty character strings are duplicated as well. This function has one more extension, which I like. So let me show how it works first. It will work like labeling groups of duplicates. Groups. And function is the same, dubs. And it will use same arguments, but also has one more option, groups equal to true. Groups equal to true. Let me see if I have all parentheses in place. Looks like I have. Now run it, and you will see third column, name groups. It will show you groups of duplicates. So non-duplicated data are labeled with 0. All NAs are labeled with NA. You can change this behavior if you want. But what's important, there are groups of duplication. For example, all 3s labeled as group number 2. All 2s as group number 3. All empty strings as group number 1. So this is important to understand which of your data are duplicated in which way. So how is looking the pattern of duplication. There's one funny example, which however show you how groups might be useful in general. Let me apply groups as a classification tool for this well-known iris data. So let me make iris data in a different way. So I will use iris object with all dubs function. And what I will do, I will round, because iris data contains some decimal numbers. I will round them to the whole values and round all columns from 1 to 4. And then, to make them even more similar to each other, before rounding, I will divide everything to 10. So numbers will start very similar to each other. And I will also apply my groups option here. And everything which I made, I will write into the variable iris dgr, for example, duplicated groups, and immediately show the result. Okay, so again, what I did, I took, I forgot one thing, name of the group, name of the data, round, iris, okay. So I took the iris data, took columns from first to fourth, so I ignore the last column, which is species, divided values by 10, rounded them to whole numbers, and calculated groups of duplicates. So now my data consists of multiple numbers. I use here the feature of duplicated and the same feature of unique and of course of all dubs to be applicable to the rows of the data frame. So you can apply it for the vector, and you also can apply it for the rows of that data frame, and it will show you which rows, not elements, but whole rows, are duplicated. And these numbers represent groups of duplicates. So for example, the first row of iris belongs to group number 2. Second row of iris belongs to group number 1. Row number 112 belongs to group number 3. What is very funny and very remarkable, that groups of duplicates correspond with species. If you remember, species are distributed in this data, like first 50 rows belong to species 1, then to species 2, then to species 3. There is something in parallel here. There is something which show you these numbers are not random, but correspond with species. How to check it? We can use function misclass. So misclass iris dgr, and then I will need to compare it with actual species, column number 5, iris species, and I will also need option best, because my numbers and species names are not exactly the same. Numbers is 1, 2, 3, and species names are Virginica, versicolor, and setosa. So to me, result is simply amazing. So we didn't do anything complicated. We just divided numbers by 10 and rounded them, and then see which are duplications between groups. And this has a precision about 23%. So 80% of iris are classified correctly with that very straightforward, I would say, dumb approach of making calculation of groups of duplicates from rounding. So very interesting. So these duplicated groups have some perspective in machine learning, and you can use them for the same purpose, to understand which groups of duplicates exist in your data. So this is it. So I told you about dummies, which allow you to convert categorical data into binary numerical data, and about how to deal with duplicates. So how to find all duplicates, but not only third, second, fourth, but not first. And also about how to understand groups of duplicates. It's advanced step, but interesting and useful in some interesting applications. Thank you very much.